So today we're going to learn about non-parametric sign tests. So we're going to learn about two sign tests today, a basic sign test and a paired sample sign test. So let's start with the first one. So have you ever had some data that you didn't really know anything about? You didn't know how the data was distributed, you didn't know what it looked like at all. But you still wanted to test a hypothesis. Well, that's when you're going to use a sign test. So our example today is going to be about basketball and throwing free throws. A recent study has shown that the average person will make 3 out of 5 free throws in basketball. So let's create some hypotheses about this. So let's make our null hypothesis that if given 5 attempts, the average person will make 3 or more free throws. And our alternative hypothesis can be the exact opposite. So if given 5 attempts, the average person will make less than 3 free throws. So let's go collect some data in my backyard. As you can see, my family is not very good at basketball, but now we have 4 data points. So we have players A, B, C, and D. However, for a sign test, you usually want more than 4 data points. So I just chose another 4 random samples. So E, F, G, and H. Now what we want to do once we have our data for a sign test is to assign a sign to them. So any number that is over 3 or over will get a positive sign, and anything that is 3 or under will receive a negative sign. So in total, we have 2 positive signs and 6 negative signs. Now, we want to assume, in this case, a 0.05 alpha, or a 95% significance level. So now what we want to do is find out what our critical X value would be. To find our critical X value, we're going to use a reference table like this one, a sign test critical value reference table. So what you're going to do is all you need to know is your alpha, or your significance level, and your N, your number of samples that you have. So in this case, we have an N of 8. We had 8 samples. So what you're going to do is look at the 8 under N and go across to the appropriate significance level. In this case, 0.05, which gives us a critical X value of 1. So now that we know that our X critical value is 1, we got to figure out what our X value is. So for a sign test, your X value is simply the lesser of your positive or negative number. So as we can see, in this case, it's going to be what our positive value is. So in this case, X is going to equal 2. Our X critical is going to equal 1. Therefore, our X value is greater than our X critical value. What this means is that we cannot reject our null hypothesis. So in a sign test, if your X value is less than or equal to your X critical value, you can reject the null hypothesis and accept the alternative hypothesis. But in this case, because our X value is greater than our X critical value, we can't do that. Therefore, our null hypothesis is still true to a 95% confidence level. Now we're going to look at a paired sample sign test. Now a paired sample sign test is when you have 2 dependent data sets and you test to see whether a certain factor statistically affected the outcome of those data sets. So today we're going to test whether Gatorade, the sports fuel drink, affects sports performance. So we're going to go back to our basketball free throw example, and we're going to test whether drinking Gatorade affects how many free throws we can make out of 5. So our null hypothesis will be that drinking Gatorade does not improve basketball performance. And our alternative hypothesis will be that yes, Gatorade does improve basketball performance. So let's go back to the backyard to collect some data. Now that we have our data, we can perform a paired sample sign test. So what we do for a paired sample sign test is we lay out our data from before, in this case they drank the Gatorade, to after they drank the Gatorade. And then if that, as our hypothesis said, if those numbers went up and they made more baskets after they drank the Gatorade, we'll give them a positive sign. In this case, every single one of our samples went up. More baskets were made after they drank the Gatorade. So in total, we have 8 positive signs and 0 negative signs. And we're going to maintain the same significance level, 0.05. So, like the regular sign test, we're going to go to the reference table and figure out what our critical X value is. In this case, we were simply asking whether Gatorade improved performance or didn't improve performance. So that means it's a two-tail sign test. So we're going to look on the reference table, our n is still the same, 8, and go over to the 0.05 for a two-tail test, which tells us that our X critical value is 0. So to find our X value, we do the same thing as with a regular sign test. So we simply take the smaller of the two numbers, positive and negative numbers. In this case, that's 0. So both our X value and our X critical value are both 0, so they equal each other. So in that case, for a sign test, if our X value is less than or equal to our X critical value, we can reject the null hypothesis. So in this case, we can reject the null hypothesis and accept the alternative hypothesis. Gatorade does indeed improve basketball performance, or at least in my backyard.